Okay, I think I'll make a start. Hi everyone, my name's Noel. For those who've not met me before, I'm a Scala developer. I work in London at a company called ITV. For those who don't know who ITV are, we're the largest commercial broadcaster in the UK. And I work on our online catch-up team. We create a lot of Scala microservices to help facilitate and aggregate a lot of the metadata that goes into creating an online catch-up platform. So yeah, thanks very much for coming. To be honest, I really thought I'd be talking to an empty room because the other three talks look particularly interesting at this time. So well, thank you for picking me over them at least. So yeah, and just to check, is that read okay at the back? So I'm trying something a bit different here. I don't actually have any slides. And everything I'm going to do, cheers, yeah, everything I'm going to do is in the REPL. Hopefully it'll work. But yeah, there's this nice plugin written by Marco. Sorry, I can't remember his name. I'll look it up. I'll tweet it. And it seems to work pretty well. So everything I'm going to show is runnable, and I will run it. And that just proves I'm not lying, I suppose. And yeah, just before we get going, I do have one warning, is that I've got quite a lot of material to cover, and I'm going to make a few sweeping statements. I'm not going to explain everything that I put on here. Hopefully, there's enough context that you could go away and read a bit more about it or fill in the gaps yourself. If you're completely stuck, then obviously do shout, and I don't want to lose anyone along the way. But hopefully, what I'm going to show over the next kind of 40 minutes is a few little steps to build a small application, which would hopefully grow over time, and then we can look at how to refactor this to make it more functional, more testable, and just generally give us a bit more confidence about the code we're going to write. So have people got experience with Scalaz? People comfortable talking about monads and monoids and things like that? Because we'll probably cover little bits of that as we go along. But like I said, if you can't fill in the gaps, please do shout, and hopefully that'll be fine. Okay, so the first thing I want to do is a couple of imports. So we like I said, we'll be using Scalaz, so I'm going to import that, and then because we're in the REPL, I'm going to be dealing with futures. So we'll just kind of get that one out of the way, just so that we don't get tripped up with missing implicits and things all the time. So I'd like to introduce you to this API. It's not real, I wrote it myself, but hopefully you can get a bit of a flavor of things you could do here. So it's a very small client that allows us to get the tweets from a particular username. So this could be maybe a particular appropriate API for that. So some function takes 3 parameters, the name of the person you want to get the tweets for, and then if you've ever done any API programming, you generally need an API key and a secret. You can tell by the return type that this is going to perform something asynchronously, and it's going to eventually give us a list of tweets back. And tweets is just a case class. Really, all we care about here is that we've got this content field that contains the information that we're going to be looking for. And this works. So we can do things like this. So we can call get tweets. That's my username. Obviously, these are not real. And then we can block on the we can block on the future until it completes. We'll just look at the first few, and I must say, like the golden rule of presentations is assume nothing will work. So this is not actually going to the internet, and it's just a JSON file in my repo. But I did download it from Twitter a while ago. So yeah, okay. And so the second part I'd like to introduce. Hi. Is it? Sorry, say that again. So when I do that? Oh, I see. Right. Okay. If I just show it, is that better? I think the things on the right, I think we'll be okay with that. If it's not, we'll just move things around if that's okay. We good? Yep. Okay. Okay. And have people come across Markov chains before? Anyone had to play with those? Know what they are? Yeah. Okay. So for those who don't, it's like a kind of non-deterministic algorithm. So you provide some seed data, and then you can then randomly create strings. So, for instance, say like with the English language, if you look at a certain letter, you have for certain letters, you can have a really good guess at what the following letter would be for a, given. So if you say you saw a Q, more likely the next word that appears is probably going to, next letter that appears is probably going to be a U. And then if you give enough data, you can start building up little kind of dictionaries and little patterns of words, and it ends up looking like maybe something somebody said. So I thought what we'd do is we'd maybe do this, but rather than just with letters, we'd do this with words. So just kind of cement the idea again. So say we had a string like this. We could then parse this, and then if we took two words at random in a sequence, we can then take a good guess at what the next word would be. So given the words my and name, that is always followed by the word is in this case. But then if we then took name and is, the next word is either going to be Noel or Christmas, just based on this dictionary, this kind of string, which I'm going to call a dictionary, we've given here. I just made up this term context of 2. If we had a context of 5, we'd then look 5 words and then see what the next one is. So the more data we give this, then the more like maybe things that I've written on Twitter would appear, if that makes any sense. And so what we can do is we can then get a couple of words, randomly pick the next one from the list, and then take that word and the previous one and kind of generally just create a nice little string. Does that make sense? Yeah? Okay. So here's the API for that. And again, this is just a made-up one, but hopefully you can see how this would work. So just a function, generate string, takes this text, or what I was calling a dictionary, and how many words to look at before guessing what the next one should be. That's going to take some time to compute, and eventually that's going to return some random string. And so we can do things like that here. So I've got a couple of functions here. We've got that tweets future from a couple of slides ago. I'm then going to wait for the result of that, and then take that list of tweets, do a little bit of manipulation on it, make it into a string basically, pump that into this generate string, and then we can then call that, wait for the future to complete. And I don't know, I actually don't know what's going to come up here, so maybe this is just some kind of weird insight into my life. But yeah, there you go. Okay, so we got a couple of things here, these kind of mandated APIs. We don't have the ability to change those or fix those. That's what we're stuck with. That's what we've got to work with. So let's try and put these together. So we had both these return futures, so we can just use a simple for comprehension. We'll flat map over those. So we'll call get tweets. This function takes a username, so we're going to pass that in. I've pulled out all the kind of configuration details off to the side because that's just noise. And for when we run this, really, we only want to say, give me a random string for a user. We don't want to say, and here's all the configuration you need to do that. In a running application, that's the kind of stuff you're probably going to give at startup. So we're going to bind to the result of whatever the getTweets method function returns. A little bit of manipulation here on the result to massage it from a list of tweets into a single string. And we're then going to pass that onto our generator and yield the result. And lo and behold, just like before, this works. And yeah, okay. Cool. So I had I just put the configuration off to the side there, and I thought I'd just take a little bit of a sidestep here, and we'll just kind of go back to basics a bit and talk a little about some functions. There's hopefully nothing too surprising what I've got on the screen here. Pair of functions, one takes a string and returns an integer, one takes an integer and returns a Boolean. And I think probably most people here probably understand that we can compose these. And so we can then create a function that, given a string, then tells us whether the length of that string had an even number of characters or not. And lo and behold, this works. That's as you'd expect. Okay, so I just have just a pause here and I think about what we're doing. So we've got this string length function, and then we take the result of that function, and then we apply a function to it to kind of turn the result into something else. And These are things we might have seen before. Say, for instance, if we're talking about lists, is that we have a list of a certain type, and then we can apply a function to that, and then that turns that list into a list of what that function returned. And then the same with futures and options, all these things. And effectively what we've got here is that functions themselves are actually functors. And so the and-then method that Scala provides is actually just the same as calling map. And if you import Scalaz into your project, then you can treat functions as functors. And so, this does exactly the same as it did before. But we kind of have this more general concept of what the thing is. And hopefully as we go along, we'll start to see where things like this might become useful. Okay. So, like I said, I had the config, and I just kind of took it out of that method because I wasn't interested in it. But effectively, we need to have this configuration somewhere. So for now, I'm just going to put this in a nice little tidy case class, which just shows everything that we need in order to get our application running, and that's API key, API secret, and then how far ahead we want to look in our dictionary in order to create our random string. And then we can create functions from this. Given a config, it returns a string that's a key, or given a config, that returns a string that's the secret. And then, we could start to think about writing methods like this now, and hopefully this doesn't seem like too surprising or particularly hard to do. And I think one implementation could look something like this. So key and secret, it's a function that, given a config, returns a pair of strings. And so we'd implement that with a new function, given that config, goes and calls these methods we've just written before. And there's nothing surprising here, hopefully, is that we've got this new function now, key and secret, we give it our config, and then it just returns what we thought it would. Okay, so we're done. We've got a way to deal with config, get it out into a nice little separate section, and then we can pump that in when we need it. If we give a different config, we get different results, but in a nice functional way is that we have no dependency inside our implementation on a particular config, and we can just provide that at runtime. So let's just have another sidestep and just think about another way we could write this. Like I said earlier, functions are functors, but we can actually think of them as monads as well. And so here's another implementation for that same function. And the more astute of you notice that actually this is also an applicative, and we didn't need to do it as a monad here, but I just wanted to keep it quite small and tidy for the slide. And so what we can do is we can call this function here, and we bind onto the result, and then we call this function here and bind onto the result and yield whatever we want. Does this all make sense? Yeah, okay. And this all works just like it did before. Okay. So we have this kind of nice monadic property of functions, is that we can then use map and flat map in order to create things that are not run until a config is given. Okay, so now that we've separated out our configuration, I think we need to make our application a bit more friendly to the way we want to use it. So I've wrapped both of the API methods that we've seen here into our own methods. And all we really need is when we want to get someone's tweets, all we really want to do, and I've said this a few times now, is just give a username, and that gets us the result back. And then that's what this getTweets does now, we give it a username, and that gives us this function, which, given a config, will go to Twitter and go and asynchronously return us a list of tweets. And then if we want to test this, we can provide a different config. If there was, say, a UAT environment that was available, or we mocked out something else, and we could provide different ways of making the same calls. And the same thing here for the generate string is that I give it this dictionary, and then this won't run until the config is given. So I can create my dictionary and then say, right, let's run this where we look five words ahead, or 2 words ahead, or 6, or whatever. And that doesn't matter until runtime. Okay? So how do we now work with these together? Because that's really the whole point of this, is that we want to get these tweets, massage the data, put it into our generator, and get some fun results. So we start to write a flat map. So we're going to have this RoundString method, takes a username, and like we've seen, we want this to return a function, given some config, returns us a generated string at some point in the future. So, like I said, functions and monads. So we can do this, and we can call getTweets, and we can bind onto the result. But the problem here, actually, is that the tweets is not going to be a list of tweets. It's going to be the future of a list of tweets. So we're in this we're going into a bit of a rabbit hole now, where we then need to have, say, another for comprehension where we then go over the future, and this all just gets a bit messy and a little bit unsettling. So what exactly can we do about this? Well, let's take another sidestep. And I'm going to introduce a new type here called reader. And we've got our two functions from earlier. And I want to show this type called reader here. And so we have this reader constructor, and all it does is take a function. And then the type of the reader has the types of what that function was originally. So the key was config to string, and so the type of this reader is reader with config and string. And then it's the same for the secret from config as well. And so all reader gives us a run method, and then the run method is this first type here. And so run is expecting a config, and then when we call run, it goes and runs that function and gives us what we want. So we can call key from config with a given config, and that will work. Like so. Now, the thing is, this has given us nothing extra now. Like, all this has done is just made this more complicated and added some types in. And we haven't actually got any extra out of this from what we were doing with functions a minute ago. But then there's an extra step we can do, which hopefully will make this a little bit better. Actually, before we do that, let's just prove that still works. So this for comprehension here, this hasn't changed. You know, what we were doing was monadic before, only needed for comprehensions, didn't care that it was a function, and it's the same now. Just as long as these types are correct, that key from config is a reader, then we're good to go. But what we can do is we can use monad transformers, and just take a very, very brief recap into what they are. In fact, there was a talk yesterday, which I think probably covered a lot of this better than I will do in about 3 minutes' time. But say we had some asynchronous computation that optionally returned a result. And if we want to then work on the value inside the future of option, is that, well, we need to wait for it to complete, and then we need to make sure that it's a sum and not a none, and all this stuff. And we end up with kind of too many monads getting in the way. So Scalaz provides what's called a monad transformer, and it provides lots of transformers for specific monad types. So there's this one here called option T. And what we do here is we provide an abstraction over that future, and then we can work in for comprehensions as if that future wasn't there at all. The only it's not so much a downside, but we're not dealing with futures of options anymore. We're dealing with a completely different type. But then the nice thing is that this respects the fact that A, the future is a monad, and B, that it knows it's an option. So if we're doing map and the thing that ends up computed is a none, then the option transformer knows how to deal with the fact that it was a none. So we're not going to get any nasty null pointer exceptions or weird effects. And it just kind of works as it would with options as well. So we could then call things like map, and that is still an option, option T. And then we can turn that back into our original type just by calling run. And then when that completes, we can hopefully get the computation we were expecting. I've kind of rushed through that a little bit, but hopefully you get the flavor of what that can do there, is that we can just call map and not have to worry about it being a future, and just deal with the fact that we've got an option in there, and that will just kind of slot into place. So like I said, we've got monad transformer, which I've just shown for an option. But then there's also a monad transformer for a reader as well. And so what reader does is, what the reader does is it will allow us to effectively separate out the two types that appeared in a function. So we've got the input and the output. But then what the ReaderT will do is it will allow us to abstract over the return type if the return type is a monad. So here, like we've got this function which, given a string, returns a future of an integer, is that we can then convert this into a ReaderT, and like I said, I'm going to make a sweeping statement alert here, in that calling this method here gives you that function inside a ReaderT. And go and have a look in the source code. It does very little, but what we have done is we've separated out here the three constituent types that are part of this function. So we now know that we're dealing with a future, and we now know the input is a string, and we know that the value inside that future when it completes is an integer. And those three things are now separated. And that's really what a ReaderT will give us. And we can do things on this that we would do, whether it's map or flat map, kind of functor and monad type operations. So the original function here, this f, returned a future of an integer, and then we can call map on that value. The function inside expects an integer, and then we can return whatever we want. So that we do a Boolean here. So we take our integer, we want to see if it's even, so that becomes Boolean. And then, again, we call this run method just like there was on the reader, except now we get a monadic value in response. So we put a string as an input, and because this function here was a Boolean, we return a future Boolean. And then I think this just works as you would expect. So Scalaz has an even number of characters in it. So back to what we were originally looking at. So we had this to begin with, and this was really what we were getting stuck with, is that we had this nice way to treat this as in a monadic context, but the problem is the futures were getting in the way. And with a little sidestep we've done into readers and ReaderTs, I think we could change it ever so slightly to look like this. So like I said, this Kleisli method, all it takes is a function, and then that function has to have some kind of monadic return type, which both of these did. They were returning futures of something. And so we now have this getTweets, which, given a username, returns a ReaderT over a future, a config, and a list of tweets. So given a config, this returns a future of a list of tweets. And a similar thing for our generateString method. So now we can really do this again. So this is what this method could look like now. So given a username, this will return us a ReaderT, which, given some config, will return us a future string, and that will be our generated string. And hopefully, like this code on the screen, like the actual for comprehension, should probably look a bit familiar. In that it's very, very similar to what we saw earlier. Like that was the one I showed right at the start, which was getTweets, massage it, put it into our generateString method, and then move on. And so now that we've managed to get the future effectively out of the way and stop our kind of comprehension of what's going on here, is that we can reason about this better and really start to work on the nuts and bolts without having to worry that these things are asynchronous or that we need config to come in at certain points. So what we can do now, we can call this RoundString method with a given username. That will give us our ReaderT. There's a function on the ReaderT called run. We give that a config, and then this function I've written here will now return a future of string. And then, just like we saw before, we can run this, and that will just give randomly generated strings from the input given. So, okay, there you go. I'll move on, I think. Okay, so I think that's quite a nice place to be in now. Is that we've got an ability to abstract over our config, so we could have different configurations for different environments. And then also the fact that all our methods, all our functions that we have no control over, this Twitter API and this Markov chain generator API, we have no real control over those, and they just return futures. we can use these two things together without them kind of getting in the way of each other. And hopefully now this will make this a little bit easier to test. So I'd like to make one more change to what we've been writing, just to see if we can make this a little bit easier to test. And I think this is probably one of the busiest slides I've got today, and there might be one other one. But I think the first thing, before I describe this, the first thing here is to say is that this code here hasn't changed at all. Like, this is what we've been looking at for the last 20 minutes or so, is that, you know, we get the tweets, we massage the data, we put it into our generator, and then we're done. But what I have done is I've created another parameter list here, which just takes a pair of functions, and this is what we've seen all along, is that for get tweets, you know, given a string, returns a ReaderT, and then for the generate text, we give that a string, and then that will produce a reader. And now what we can do is at runtime, when we're writing some tests, we can provide our own implementations of these methods. So, like, you know, we don't have to go and call Twitter, or we don't have to go and do an expensive computation. Because actually, we don't really care. In the code we've been writing, we don't actually care that we need to go and make an asynchronous call. You know, it might be that we could get charged for making calls like that, so we don't want to do this too much. Where really all we want to do here is effectively test that the output we get from one function gets massaged and put into the other function. That's all we're really testing here. And so a nice way to test this, I think, would be to use something like ScalaCheck. People familiar with ScalaCheck? Yeah. Yeah, so anyone not? Okay, all right, so ScalaCheck is called property-based testing, and you define certain properties about your code, and then ScalaCheck will run those properties. It will test those properties and assert that they're true for randomly given data. So what we could do here is we could create a function that randomly generates a list of tweets, and then we could follow that data all the way through and make sure that the result that comes out of the other end is correct. So first thing we have to do is import some ScalaCheck. And I'm going to make another one of these sweeping statements here. And that I'm going to bring another library in as well, which is, it's called the shapeless contrib library, and there's a ScalaCheck module in there. And I'm not going to explain fully what it does, but if you import this into your project, then you can generate arbitrary instances of case classes with no boilerplate code at all. So the fact that our tweets class was a case class means that just by having this import in here, this will generate arbitrary random tweet objects just from the information that the compiler can get hold of. And this stuff is absolutely magic and brilliant. And it's got more use than just with ScalaCheck. You can use this for creating Scalaz equal instances, and I think Argonaut JSON works very well with this now as well. So we'll import these. And then this is one of my busiest slides, actually. So here's one attempt at implementing a test for this property. So we'll take it line by line, but I want to start here. And that this is really what we've been writing today. So we've got this random string. We'll give it a pair of functions. We'll give it some name, and then that's going to give us an output. So the function we've got here takes this arbitrary list of tweets. So the ScalaCheck library will populate this with a list of tweets, and it knows how to create arbitrary tweets based off the fact that we've got this shapeless contrib library in. And then for this test, we don't care about the name being passed in. Like, we're going to ignore that here. And all we're going to do is wrap this in a future and return it, and then we're good. And again, for our what was our Markov chain generator, we don't actually care that that produces a random string for here. All we really care about is that the function, the data that was received to that function is right. So what we could do is we could just return that and then make sure that whatever we get from our result appeared in the list of tweets in the first place. So this works, and then we get a nice ScalaCheck property. And now we can run this, and this will run 100 times with different lists of tweets, and will tell us that it's all good. So that's quite nice. So yeah, I mean, like I said, I had to apologize for this slide being a bit boilerplatey. So maybe it's worth seeing if there's something we can do about that. And so one thing we can do is abstract over the ReaderT. So this is what we had originally a couple of slides ago. And then notice here, like I've been saying, is that there's actually nothing in this method, in this for comprehension, that actually takes advantage of the fact it's a ReaderT. Like, you know, we want it to be one because we want to inject our own config later. But for the purposes of this method, we don't care. All we care about is that the result that comes from this function gets massaged into a single string, and then that's passed into our other function, and we get that as a result. So what we could do is we could completely abstract over that monad into something like this. So I have a type parameter, which we constrain to be a monad, and then our functions actually can return different ones. And then our whole function itself returns a string inside whatever monad these were in the first place. And notice, this code hasn't changed at all. But the compiler knows that we're dealing with monads here, so we can do for comprehensions and flat maps and things like that, and this will all work. And so what we can do now is, for our production and maybe our integration tests, you know, we're going to want to use our ReaderTs as we did before. But when it comes to writing a unit test and we want to check that this method actually does what it says, is that we can write much nicer tests. And this code here has exactly the same intention as what we had earlier, but without all of the kind of noise that the ReaderTs were getting in the first place. So I'm using the Scalaz ID monad here, which, if you're not familiar with, has no effect. It's actually written in the library as a type alias. So it's like type ID of A equals A. So the compiler knows that you can just get rid of this when you need to. So like I did earlier, this function here just returns the value that's given into this test, and we don't care about the name. We pass through the text that goes straight to this function. And now, this RoundString function doesn't return a ReaderT, it returns an ID of a string, because we're dealing with ID functions here. So we don't need to call await, we don't need to do any blocking, we don't need to run it with some arbitrary config that we're never going to look at. And then we just get a nicer test. You know, and this works just as before. And we can run this all day long. And this is running with 100 tests of different lists, and it's making sure that what we put in is what comes out in some way. Okay, so we're all good. You know, we've got a nicely working application. I think we're pretty confident that we've used some interesting types and some interesting tests, and we're good to go. And then all of a sudden, the boss comes along and says, "Actually, I'd like a new feature. Is that I think we should put a little bit of logging in the application. You know, make sure we're sending our clients the right strings they asked for." And so maybe our unhelpful API gives us something like this. So we're kind of stuck with some log method given some text. It's going to return a feature that will complete at some point in the future. And so we can change our nice implementation to look something like this. So this is as before, but then I want to add a log function here. So string to some kind of M of unit. And then inside my for comprehension, like I said, I don't care about the result because it's just going to be unit. But I need to go off to the outside world and do some logging that we've received these tweets. And then I'm going to do a second log as well, just to keep everyone happy that we're sending the right string to the right person. Okay? So now it gets a little bit more tricky to test, because what we were doing before is we were using our functions that were dependent on this method just to pass the data through, and we could see what was coming out the other side. But now we've got this function that returns a unit. We can't do anything with that. We're good Scala programmers. We don't want to use side effects. Is that we really want to make sure that if something says unit, it's not going to do anything else. So it's a bit questionable now how we test this, because if we just plug in some dummy stubbed out method, then we've got no way to verify that it's actually being called. So what we can do is we can change our test, which we wrote originally to use the ID monad, and we can use something else that would maybe keep track of what we were calling and when. And this is a possible implementation. I've had to use a type alias here, sorry, just to make things fit on the slide. But are people familiar with a writer monad? No? So I suppose you can think of it as you pass in a type here, and then you effectively write to the monad with a value of that type. And this type here has to be a monoid. So the nice thing about map monoid is when you append to it, as long as the value type itself in a map is a monoid, then all the strings that are equal then get appended together, all the keys that are equal, their value types get appended together. So if we had integers in the default implementation in Scalaz for the integer monoid is addition, every map will just add those numbers together for each time it sees the same key. And so our test now looks like this. So our dependent functions now return writers of that type that we were looking for. So this is a writer of a list of tweet. And then Scalaz has the function set, which returns whatever the value you call it on inside a writer. And then you have to give the value you're writing to. And you can think of this way you're writing as like a journal or a log or something else. So when we return tweets, at the same time, to our writer, we want to write a single map with a key of tweets and the value 1. And that means every time this gets called, the number of the value where the key is tweets will get incremented by 1 each time. Similarly, for when we call our text generation function, we want to do the same here, and we've got a key here for what we're sending our text. But then for the logging, this is different because it returns unit. Like there's nothing to return. So we have this tell method, which itself returns nothing, and whatever we call that on, that's get written to this journal. So now, our RoundString function here, originally it was returning a ReaderT, and then we changed it to return ID, and now it returns a writer. So when we run it with this .run, which is on the writer monad, that actually gives us a tuple in return, and the first value in the tuple is everything that's been written to, and the second value in the tuple is the return of what we were really looking for. So for this method now, we actually don't care about what we were returning at all. So we can just look at what got written to. And it should look something like this. So we're going to have a map which is called tweets once, which says that tweets was called once, text was called once, and log was called once as well. And so we get a property, and then we can check that the property is always going to succeed. And of course, no, it doesn't, because log was actually called twice in that function. And so our test should look like this. So what we've got here is effectively a nice kind of hand-rolled, simple implementation of maybe a little mocking framework without all the kind of overhead and boilerplate that comes with that. And these are just purely functional principles that build this up. And we could change this map to be a list, and then what we would then get returned is maybe the sequence in which things were called, or I don't know. The lists are endless. We can basically write whatever we want. And don't forget that our original implementation that we were testing hasn't changed once since we made it return any abstract monad. So does this all make sense? I'm seeing a few blank faces, but okay. But that's actually all I had time, or all I wanted to talk about today. So just a bit of a recap of what we really did here. So we were given, a few unhelpful APIs, kind of constrained with what we could do with them. But we found a nice way to work with them, is that, we wrap these up in our own function and we separated out the config from anything we needed with it into using the reader and ReaderT monads. And then we made integration easier. So we almost did our own dependency injection here, just with being able to provide our own functions which go and do the things we want at implementation time. So we can change these, like I said, we can change these for unit tests as maybe we do something different in production, and maybe that would be the same as integration tests and things like that. And this has all been made possible really with some very, very powerful libraries that are out there in the Scala ecosystem. So, liberal use of Scalaz. We've got this great library with ScalaCheck, and managed to use some shapeless in the plumbing of that really to make this quite easy to understand. Yeah, so like I said, that's all I had time for. Thank you very much. If you have any questions or anything, yeah. This one here. Yeah.
Where is it?
Yeah, here. Yeah. Yeah.
Very nice talk.
Thank you.
I have a question about your for comprehension.
Yeah.
We tried similar things, and they tend to work pretty well up to the point where actually you realize that all those features, they do serialize inside the for comprehension. And of course, if you have dependencies of variables from one line to the other, it's fine. But if you don't have any dependencies, it feels like a bit of a shame that actually you have to wait in the for comprehension. So how would you solve that?
Well, I mean, I suppose the first thing to jump out is we maybe use applicatives instead. So applicatives, the key with monads is they're effectively a sequence of instructions. And applicatives are not. When you work with applicatives, generally everything, you can set your futures to run asynchronously, and when they've all completed, you then have to give a function of all the internal types of those futures. And of course, because these are all monads I've been showing today, they're also applicatives. So that would be how I would do that. I mean, alternatively, if you do have for comprehensions, you can always, and if there's no dependency on previous lines, you can always start the futures first. So just like, assign it to a variable and then bind on that variable in the for comprehension, and the future's already running. So but if it depends on a previous line, then there's nothing you can do.
Yeah. So that's the way you would suggest. So first declare define the futures elsewhere, and then run.
I would prefer it if it was applicative. I think that makes more sense. But you have to work with what you're given, I suppose, some of the time. So
right. Thanks.
No more questions? No.
Great talk, by the way.
Thank you.
So my question would be, how does this compare to the cake pattern, which of course means different things to different people, but at least at the end, what you gain is kind of similar testability, let's say.
Yeah. I suppose I've been burnt a few times by the cake pattern, maybe, joining projects after they've started. And, I think the thing with the cake pattern is you can often get into making sure things are initialized in the right way. Whereas with this, we've kind of removed a lot of the dependency completely, and that we're just dealing with monads here. And so as long as we make sure that we've got everything we need, like when we run it, then that's all we really need. And I find it makes things easier to break down and compose, is that we don't need dependencies on certain traits or other things. And yeah, I actually have limited experience with kind of working with cake pattern, but from what I've seen, I personally prefer this way, because it feels very kind of like building blocks, I suppose, that you have these very small things that are very easy to plug together. So,
thanks.
Yeah.
Yeah, so do you get a lot of resistance programming this way?
I think,
because I like it, but
yeah,
I mean, if I would do this, then I'm not sure if my colleagues will appreciate
Sure,
it.
yeah. I mean, I completely understand that. I think probably the hardest thing with this is introducing it. And from my experience, this approach is very hard to retrofit into an existing application because you effectively have to drill down all the way to where you're making the kind of primitive calls, I suppose, and then make sure everything can build from that, and then it tends to kind of spider out to the whole project. So in my experience, yeah, I've seen resistance, and that's been quite hard because the projects have been up and running. But on a project that's been brand new, and if people are keen to try this way, it really seems to work out quite well. So,
Would you advise against introducing it in an existing team then, or
an existing team or existing project?
Existing team project?
Yeah, I think it would be maybe on a very isolated part of a project, but as soon as things start to touch other areas, it tends to kind of spider out, and you find you have to have a reader here and a reader here, and it kind of goes all the way back to the kind of root of your project, in my experience anyway.
Okay, thanks.
All right.
Two questions for the price of one. We had an earlier question about parallel composition of features. I wonder if you could say anything about task. I'm maybe a little bit surprised since you have other Scalaz features, you haven't got task in here, and maybe you have some thoughts on that.
Honestly, I've never used task. I just the projects I've been on. In fact, the project I used this on was actually using finagle features.
Right.
So I've never used task at all. So
Okay.
yeah, sorry.
Fair enough. That's fair answer. So the second bonus question is: have you looked at cats at all, and do you have any opinions there?
Not yet. No.
Right.
I'm sorry. They've
Another easy
been two
question.
rubbish answers. Sorry. No, I haven't looked at cats, but it seems great. And actually, I have looked at it a little bit, and I believe a lot of the there's like a lot of shapeless use for like auto-deriving functors and things like that. I believe similar to what I showed here with auto-deriving arbitrary generated case class instances. I believe the same happens with functors, but I might be completely wrong on that, so don't say I said that.
Okay, yeah. Thanks.
One more question.
Also two questions. The first one is just a little technical detail, but on your slide with the writer monad, you were calling set and tell on a list. How does that work? Is that an implicit thing?
Yes. So when you import Scalaz, the world, you can call .set on anything, and that will return a writer of the correct type. So in this case here, so if we just look at the bit I've got highlighted, is that's going to return a writer of something, and then the monadic type is this value here, so that's the list of tweets. And then that something is then given by the parameter to set, so we're dealing with a map from string to int here. Right. So that's like so. And then for tell, that's a writer, and the monadic type is unit, and that's like set. But then the value you write to is what's called on the .tell. So again, this will return a writer of map of string to int with unit.
Right.
Is that okay?
Yep, that makes sense.
Yep.
And the other question, an accusation I often hear level against the reader monad is that it doesn't handle multiple dependencies very well. If you have to depend on some config and a database and something else.
Yeah, absolutely. And that's something I kind of skirted around here. But there's a function on the reader called local, and it's contravariant, basically. So say we had another part here where we did call the database, and we had some database config, is that what we might do is for that, we might just have a reader. Let me go back to a reader slide. I think.
So is the idea basically you have an Uber dependency which holds all other dependencies, like a context?
Yeah, I think so. Yeah, that's the way I've done it before. So you'll have like an application config, and then in that you might have your Twitter API config and your database config and things like that. And then your readers that are specific to those, you know, like in this case would be maybe future, database config, and then string. And then when you're using that in a more general sense, you can call .local on the reader, and then that takes a function which, given the like more wider type, that function then tells you how to get what you want. So it'd be like a function from an application config to a database config, you know, something like that. So.
Okay, thank you.
Yep. No. No. Oh, okay.
One last.
With this approach, did you notice you had to use less integration tests, and then basically less bugs in your code?
So we still had integration tests, but then they tend to be at a concrete level. So rather than them being, you know, an abstract, any monad will work here, is that, you know, we do want to plug in certain things. So, you know, if we're going to go, if we have the function that goes off to a Twitter API and makes a call, then there's nothing we can do about that. That's returning in the future. And when we're doing integration tests, we want that to happen. And so we would use ReaderTs for that, but we would just basically inject, we'd mock out maybe one layer and then make sure that everything else worked with that, and then we could check that the function worked. The function was getting called properly with whatever was getting from the outside world. Okay?
Yeah, okay. Thanks.
Okay.